Welcome to this video. In a previous video, I taught you how to graph horizontal and vertical lines given the equation of the line. Then I taught you how to graph linear equations given slope-intercept form. This video will give you 4 more examples on this topic, how to graph linear equations that have been given to you in slope-intercept form. So let's get started. Here we have the equation y equals 2x plus 1. So our y-intercept is 1, or really it's the ordered pair 0, 1, and our slope is 2, which we can rewrite as 2 over 1. So remember, we always start at our y-intercept, which is this point right here. Then we use the slope to tell us what to do. So the slope tells us to go up 2 and then over 1 unit. We continue this pattern until we run out of space. Alternatively, we could also go down 2, because going down 2 is a negative direction. And then we could go to the left 1, which is also negative. Notice that the negatives cancel out, and we still end up with a positive slope when we do that. It's a good practice to graph as many points as you possibly can so that you don't have what I call drift, where you have 2 points that you're connecting with a line, and then when you get to the edge of the graph, by the time you get there, the line isn't really where it's supposed to be. Again, in my previous video, I mentioned it's a good practice to get into the habit of labeling your lines and drawing arrows to indicate that it extends infinitely in both directions. Let's do this next example. What is our y-intercept? Well, if we wanted to, we could write a plus 0 here. There's nothing there, so our y-intercept is the point 0, 0. Our slope is 2 over 3. So this means we start at the origin. It means we go up 2 units, and to the right 3 units. And we can continue that pattern. If we want points on the other side of the y-intercept, we can go down, which is a negative direction, and then to the left, also negative. Notice that the negatives cancel out, and we still have a positive slope. We connect our points with a line, making sure it covers the whole graph, and then we can label that line. Let's do 2 more examples. Here we have the line y is equal to 3x minus 2. So our y-intercept is negative 2, or really the ordered pair 0, negative 2, and our slope is 3, or 3 over 1. So we start at negative 2, we go up 1, 2, 3 units, and then over 1. We can continue this pattern until we run out of room. If I want points on the other side of the y-intercept, I can go down and to the left, like so. Then we connect all these points with a straight line, making sure it covers the whole entire graph, drawing arrows to represent the fact that it extends infinitely in both directions, and then labeling the line. Let's do this last example. Our y-intercept is 0, 2, and the slope is negative 3 over 4. So we start at 2, we can go down 1, 2, 3 units, and then over 1, 2, 3, 4 units. It looks like the other point would fall off the graph, so I can't have another point on that side. Let's see if we can have another point on the other side of the y-intercept. So remember, negative 3 over 4 is the same as positive 3 over negative 4. So what I could do instead of going down and to the right is I could go up 3 units and to the left 4 units. And that will give me another point. Again, we can connect these with a line, making sure that this line extends across the whole graph, and then labeling this line, negative 3/4 x plus 2. And that's it.